Alright, so now moving on to graphing out tangent functions. So we just recently took a look at graphing sine and cosine, so now we're going to move on to tangent. If you got your unit circle, take a look at that. I know some of you guys have your unit circles. You might have filled out the tangent, which would be great to help us figure out what's going on with this graph. If not, that's okay too. Starting at 0 radians, when we talk about, this segment right here, trying to find the slope of that, which would be the change in y or the change in x. So 0 divided by 1, well, right here, our tangent would be 0. If I take 1/2 divided by the square root of 3 over 2, which would be here, our slope of this line, would be 1 over the square root of 3, which would simplify as square root of 3 over 3. Tangent at pi over 4 is going to be 1, and the tangent at pi over 3 would be the square root of 3. Bringing us up to the tangent of pi over 2, which is 1 over 0, and there it's going to be undefined since your change in x is 0, and we can't divide by 0. Now notice as we flip into the second quadrant, that now your slopes are all negative. So we've got negative square root of 3, we have negative 1, we have negative square roots of 3 over 3. And then we're back at 0. And then once we get down into quadrant 3, those slopes end up turning out to be positive again. And so when we take a look at this graph, so we're going to go out to 2 pi. Here's pi. Here's pi over 2, here's 3 pi over 2, and here's pi over 4. And so 3 pi over 4 and so on. You guys have got that. I'll finish filling this in. Alright, so there's my x-axis. I'm going to go ahead and use 1 and negative 1 since we've been working with those with sine and cosine. And I'm going to plot out some points now. So the tangent at 0 is 0. The tangent of the square root of 3 over 3 is a little less than 1. So we're going to go over here. Tangent at pi over 4 is 1. And then the square root of 3 is greater than 1. And then all of a sudden at 90, or at pi over 2, it's undefined. So what are we going to do at undefined values? Well, that's where we're going to throw in an asymptote, because our function at pi over 2, we are not going to have any sort of solution there. Alright, then I get down to 2 pi over 3, which is negative square roots of 3. I've got 3 pi over 4, which is negative 1, and then I have 5 pi over 6, which is negative square roots of 3 over 3. Getting to pi, which is 0. And then at 7 pi over 6, we get to the positive square roots of 3 over 3. Then at 5 pi over 4, we're at positive 1, and then we're at positive square roots of 3 again. Until all of a sudden I hit undefined once again. So I get my vertical line here. So at 3 pi over 2, we are creating another undefined value. So if I start to look at what this graph looks like, and I should actually have this piece a little bit, it's going to, I didn't really plot out my points all that well here. It should look something more like this. It's not as bad, but I'll graph it out much better as we get to the next part here. But that's kind of what our graph of tangent looks like. And here, we'll show you a better picture of it here. So here's our tangent of x. I've only got from 0 to 2 pi that's being showed on the previous one, but we start at 0. You can see that it's increasing, and then you got a negative slope, and then it becomes positive, and so on. And, this is definitely going around that circular function that we've been talking about. Tangent is a little bit different, obviously, as you can see by the looks of the graph, than sine and cosine. One thing that is different than sine and cosine is its period. It has a period of 1 pi, unlike sine and cosine, which was 2 pi. Because if I start right here, right there, there's one complete cycle. Even the fact that you've got your asymptote that is on this function as well, okay? So picking that up and moving it to the left and to the right. When it comes to tangent, there is no amplitude, okay? And amplitude does not exist when we talk about tangent. So just kind of a heads up with that. The asymptotes, we are most definitely going to have some asymptotes that are going to be here. And our asymptotes are going to be when x is equal to, as far as the parent function goes, k pi over 2, where k is an odd integer. Write that a little too small. Okay, so we're looking at 1 pi over 2, 3 pi over 2, 5 pi over 2. That's where our asymptotes are going to be. Our domain is going to include all real numbers with the exception of where our asymptotes are. So x cannot equal those odd multiples of k pi over 2. Okay. And our range is actually going to be all real numbers now, because you don't have a maximum and we do not have a minimum. As far as a y-intercept goes, our origin is going to be our y-intercept, and x-intercepts are going to be all the multiples of pi. So we're going to be using k pi, and k can be any integer. Since we're looking at 1 pi, 2 pi, 3 pi, 4 pi, anything like that, as well as on the opposite side of things. So when taking a look at the graph of tangent, just notice the difference between it. The big difference, again, is the period, as well as the fact that you have the asymptote that's going along with it. Technically, we do not have technically there is no midline for your tangent. However, I am going to make reference to a line, because as we take our graph and we eventually shift it up and down, you know, this line right here is going to be shifting, so like your x, what would be your x-intercepts are going to be moving. So technically it's not the midline because there is no maximum or minimum, but just kind of wanted to let you think about that. All right, so as far as the tangent function goes, be aware that we can have all of the translations that take place for tangent as well. Okay, so our period here, the one thing that we just have to be careful of it is that, again, your period is pi, so if we're stretching it horizontally or compressing it horizontally, we're not taking 2 pi divided by b, we're taking pi divided by b, and so that will stretch it or compress it. Vertical shifts is still going to be, so here's where I'm saying it's more of a vertical shift than a midline. So k is going to tell us if we're going to shift our function up or down, and phase shift of our value of h is going to be telling us whether we're going to the right or to the left. Notice that we don't really have anything for a because there is no amplitude when it comes to the tangent function, but a is still going to be important to us because there might be some sort of reflection that takes place with it. So what I want to do here is take a look at graphing a few of these out. I'm going to pause it for a second. Divided by 1/3, and that's going to give us 3 pi for our period. Our vertical shift, we are going to be going down 2 units, and phase shift, there is no phase shift right now. All right, when it comes to tangent, there's not like the 5 critical points like we had for sine and cosine, but you do need to think about what is your period, and then halfway at the halfway point of your period, that's where your vertical asymptotes are going to be. And then we will start at 0, 0, and it'll be an increasing function up until that asymptote, and then it's still going to be an increasing function on the other side of that asymptote as well. So kind of keeping that in mind. As far as the period goes right then, it's 3 pi, so I'm just going to go ahead and say here's 3 pi. So then half of 3 pi would be 3 pi over 2. So with this being the tangent curve, I know that at 3 pi over 2, we are going to have a vertical asymptote. Now, another thing that we have to kind of keep in mind is that we are shifting this down 2 units. So like I said, there's not a midline, but I am going to shift what would have been my x-axis down 2 units. And so now as I plot my points, where I would have normally been starting here at 0, 0, now I'm going to start at -2. And then my function will be increasing up until that asymptote. Then it's going to cross over that, what do I want to call it? It's not midline. I want to call it something else. Just trying to think of a better term. I don't know if it's not right on your sheet, but I mean, it's just kind of where your axes have changed. Now, so it's going to be crossing over this line here where 3 pi is, and so it's going to be increasing from that interval. Now understand that you can also do this if you wanted to graph more than just one period. So this would be -3 pi over 2 here. And so our graph would be going down here, and then at -3 pi, it would be increasing. So there's 2 cycles of what this function of tangent would look like. All right, let's try another example. Okay, so we'll try this one. This time our period, we're going to take our pi and we're going to divide it by 1/5, which means that 5 pi is going to be the length of the period. So once again, working with tangent here, I'm going to go out to 5 pi and half of 5 pi, so 5 pi over 2, that is going to be where your asymptote is going to be located. So at a positive 5 pi over 2 and -5 pi over 2. And I can say both those because there is no phase shift that's taking place here. We are going to, however, shift this up 3 units because there is a vertical shift. So with that vertical shift happening at +3, I'm going to make sure I draw in kind of like my x-axis at +3 here. And now graphing it out, it really is, you just got to kind of think about what that graph looks like. Or starting at what, again, not the midline, but what is acting like the midline here, and then increasing from there, and then we'll cross over that dotted line again at 5 pi, and it's going to be increasing on the other side of that asymptote. And if I wanted to go onto the other side of the graph here, oops, put this up here, you know, it would be looking something like that. And there's your tangent function. All right, so what I want you to try and do with this example is see if you can, go ahead and hit pause, and try and see if you can come up with a sketch of this tangent function. All right, so hopefully you came up with something that looks like the blue line that's graphed there. And the reason why it's here is because you have to be careful because there's that -1/2 that's out in front, so there is going to be a reflection over the x-axis, and you know, if you are waiting to do that reflection at the end, remember that you'd have to factor out that 1/2, so you'd have 1/2 tangent of 2 times x plus pi over 4 minus 2. So thinking about the fact that you would be, you know, shifting your graph down 2 units, but then reflecting it over your x-axis, which would be making it up 2. But if you just know that really you're going to reflect over that, your vertical shift line too, that will help you. So I have a period of pi over 2. So halfway, pi over 2, cut that in half, you get pi over 4. So pi over 4 and negative pi over 4 is where our asymptotes are going to be. And then you can kind of take a look at our curves. I put the dotted one in here just so you could see what it would be like if that was a positive 1/2. Now if I just get rid of this, and then you can kind of see what the line is that you're supposed to have. All right, so that is your tangent curve.